Okay, so you'll notice we are still in our number system, and we're going to be looking at our standards 5 through 6A. And in this particular standard, you are going to be responsible for understanding how to write an integer and also how to graph. And then, of course, be able to describe the meaning of those integers too. So that's what we're going to be focusing on today. Understanding what an integer is, how to write it, and how to graph it. Before we do that, we have to understand what is an integer. Well, hopefully you understand what whole numbers are, because integers include all whole numbers, and if you don't remember, it's our counting numbers, including 0. But along with all whole numbers, we also need to include what's called their opposites. And what we mean by opposites, we're talking about numbers that are the same distance from 0 on a number line. So if I were going to give an example of that, I would use a number line to help me. And I'm going to have my scale count by ones. So if I had the integer 4, and this 4 could represent something like having $4. I have $4 in my pocket. Well, obviously, if I have $4, the opposite would be me owing $4. Would you agree? Yes. So in this case, if I were to graph the integer of 4, I can see that it is graphed here on this number line. And the opposite would be as if I folded that number line in half at 0, it would have a number that it matches up with, which would be that -4. So we have the integers 4 and -4, where we can say that these are examples of opposites. And where they would be placed on the number line. Here, this is 4 units from 0. And here, same thing, 4 units from 0. So they both are that same distance from 0 on a number line. So when looking at this, would 1/2 be an integer? Would 1/2 be an integer? Is it one of our counting numbers?
No, it's all whole numbers.
No, we're looking at all whole numbers. So in that case, would we see any decimals as integers?
No.
Nope, and no fractions either. So again, we're dealing with just those whole numbers that are positive and negative. So with this definition, we have to be able to understand, what do integers mean in the real world? How do we determine what makes something negative, and how do we determine what makes something positive? Well, we have key terms that we might see in the regular world just out there. Those of you that watched the football game recently, okay, at times, they don't say, oh, that person did a +10 towards the Seahawks goal, or that person did a -5 in the direction of the Patriots goal. They don't talk that way. They talk about it as being a gain of so many yards, right? Or a loss. So right there, anytime you heard the word gain, they were talking about a positive motion. for that team. Anytime they talked about a loss, that team went in a negative direction from their goal. You might also see this in terms of money, also with a gain and loss, like in stocks and so forth. We use these terms to represent that positive and negative direction. You might even see something like hearing about an increase. That would represent that positive direction, and therefore decrease would be represented for the negative direction. You might hear the terms above and below, where you might hear the term above sea level, below sea level. So right there, that tells us sea level would be our starting point, or in this case would represent our zero value. You might even see that when they talk about temperature, the above and below. But we always usually start and base it on the 0 degrees Fahrenheit or 0 degrees Celsius. But again, we can talk about above, so many degrees above 0, or so many degrees below 0. Because if we talk about the temperature, and if I say it is 42 degrees outside, most of us understand that that's 42 degrees above 0. We have that as our reference point. So we talk about that above and below. Those of you that deal with money, how many of you like money? Oh yeah, everybody loves money, right? Unfortunately, most of us don't have enough of it, right?
I would never have enough of it.
Okay, well, if you are familiar with whether you have your own bank accounts or your parents have talked to you about bank accounts, they might talk about putting money into their account, which would be like a deposit. They deposit money, which means they are putting money into their account so they have access to it to be used later on. You might even also hear that you have a credit in a store. Maybe a store gives you credit where basically they're saying you have so much money that you can spend in their store before you have to start using your own. So you basically have more than what you started with. That would be in that positive direction. But sometimes with money, we deal with some negative aspects, which might be like the term debt. Exactly. Those of you that are familiar with such things as called debit. Whenever you use a debit card, you're actually withdrawing money from your account to pay for something.
But I like at a gas station or something, when my dad gives the cashiers the credit cards, they always say like credit or debit.
And so there's a difference. You're right. Because credit, sometimes Americans think of this term different than what it actually means. Because credit means money is being loaned to you until you can pay it back with the credit card. But if you're given credit of something, you are given so much money. You're given a credit to that. But on a credit card, it's money that's given to you by the bank, but with the stipulation that you will pay it back. And the difference is, when the cashiers ask for debit or credit, debit will withdraw immediately. Credit, you actually are given kind of a loan within a month or so. There's a time period that you have to pay that money back before you might see something called a fee or interest applied to where you actually have to pay more money. So, Daniel, I'm glad you brought that up. So you do understand the difference between the credit that I'm using here and the use of a credit card. Okay, everybody okay with that? Okay, also, anytime that you use that debit or you're paying a fee, it's actually what you're doing is you're making a withdrawal from your account. money is being taken out. You no longer have that money because you've used it for something else. Now, obviously, there's going to be a lot more terms that you might see that it would apply, but this will give us a general idea to help us determine what is actually a negative number and what would be a positive. Carson.
Would O be one?
Say that again?
O, like I owe you money.
Owing, yeah. If you owe someone, that right there would tell you that you would go into the negative because you would be losing money to that person because you owe them. Exactly. That would be another way to put it. All right, any questions with these terms here? Because you are going to see some of these on your homework today. Okay, so now that we have a knowledge of what negative and positive mean, or how it can be used in the real world, there's visuals that we can use to show positive and negative values also, and we call them number lines. Sometimes you may see a horizontal number line, sometimes you might see a vertical number line. But a lot of times, usually label 0 somewhere on those number lines. In fact, you could have a number line that doesn't even have 0 labeled. But somewhere, if you were to continue that number line, 0 would be there. But we're going to make sure, we're going to put 0 in the middle on both of these to basically show the difference between our positive and negative. Now, any point that I go to the right of my number line, in this direction, I am always going to be dealing with a positive integer. So when I say positive integers, I could be using the examples of 1, 10, 23, anything that is positive. Okay, when I go to the left, I'm dealing with negative integers. And when I write negative integers, all I'm doing is I'm placing a negative in front of those values. So those are a few examples that you would have for negative.
I sometimes instead of like heading up the whole word I'll just put like a
And that's what it is. It's that subtraction sign. Yep. When you show a negative, you're using that subtraction symbol or the minus sign. Exactly. Now, a lot of times, you might see the positives written with a positive symbol in front of them also. They are not needed. If a number does not have the negative sign in front of it, it's automatically positive. But if it helps to put the positive sign in front, you're more than welcome to do that also. Okay, so any of these slash marks would also be representing negative integers. Now, same thing. If I'm going to go up, these are going to represent my positive integers, and going down is going to represent my negative integers. And just like any scale that we've used, if I start with 2 here, what do I need to make my next one?
4.
Yeah, I would count by 2s. It'd be 4, 6, 8, 10. And then what would be my first one going down?
1.
Not 1.
Negative 2.
Negative 2. Negative 4. Negative 6. Negative 8, and so on. I need to count consistently. Each mark is going to represent the same distance from one mark to the next. So keep that in mind as you are doing your scales. But is everybody okay? What is positive and what's negative on a number line?
Yep.
Now here's the next thing. 0.
Oh.
Now, is 0 included in my arrows here?
No.
No, because 0 is neither positive nor negative. Okay, so that's something that you have to keep in mind. 0 is neither positive nor negative. It is neither.
This reminds me of a graph that has like 4 squares because it has negatives and positives on each one.
And a lot of you, because we've already done our quadrant
That's what I was
plane with the coordinates, you're already familiar with this number line that I'm talking about because that's exactly how our coordinate plane works also. Okay, so we have our positive and negative values. So if I go back to my definition, I had that term opposite in the definition. And I said opposite meant the same distance from 0, right? So if we look at the next page of our notes, that's what we're going to be referring to. We're going to be referring to the opposite of a specific integer. So right now, I am going to start with an example. And my first example is just going to represent the integer 3. Okay, so my example of an integer that I'm using is 3. Now, if I wanted to write the opposite of my integer 3, we talked about 3 would be 3 units to the right of 0. So what would be 3 units to the left?
-3.
Yeah, we'd have that -3. So we can say that the opposite is -3. Now, if I wrote -13, what would be the opposite of -13? Yeah, +13.
Is this going to be our homework?
If I wrote 25 down, the opposite of 25? -25. And yes, Merritt, you're on the right track. So right now, some of you are saying, okay, this is making sense. So right now, I'd like you to come up with 2 other examples to write the opposite of an integer. Okay, now hopefully when you shared with each other, you agreed with what your opposite was. But what if I put 0 here? What do you think the opposite of 0 is? Daniel?
0.
Exactly, 0. Because if you were to fold it on the line, what is 0 matching up with?
0.
0. It is up with itself in this case. So the opposite of 0 is 0.
What?
Now, if you take a look at the next, this kind of gets a little confusing because now it's asking for the opposite of the opposite. So let's look at an example. I have integer 3, and I know that the opposite of that is -3. So if I said the opposite of -3, because that's my opposite here, what am I really getting? 3. So what would the opposite of the opposite of 3 be?
3.
3 gets back to the original number. And we can see that example here. So anytime if I have the number 3, the opposite of 3 is? 3. If I have -7,
-7.
it's going to be -7. If I have 31, it's going to be 31. If I have -42, it's going to be -42. Okay,